All right, good morning, everyone. How are you? Welcome to your favorite class. All right, so I got plenty of good emails over the weekend. You brighten my day when you send me a good question during the weekend. You make me remember that how much I love cost analysis when I can see that you've been thinking and trying to figure things out. So never feel like you're disturbing me by sending me an email, because I'm here to help you and I want you to learn the class and I want you to enjoy the class, and so let me help you do that. Homework 5 is due now. Homework 6, I've just given you the paper copy of that. I don't think I've posted it on iLearn yet as the PDF, but I will. I'll load that today. A week from today is exam 1. So that's your first opportunity to earn some real big points for the semester, right? I'll tell you a little bit of information about the exam here on the next slide. But what we're going to be talking about today is present worth analysis. We're doing that today, and we're also extending present worth analysis into the next lecture. All this material is included on the exam. So everything will be included on that exam up and through Thursday of this week. All right. So let's take a look at that. Exam 1. It's going to be in our computer lab. And the reason why we're going to be in there is because you're going to have a question related to Excel. You've learned some good things with Excel, and I'd like you to get the opportunity to show me what you know on Excel. And so there will be concept questions, which is like a short answer kind of a thing, just to show that you understand the fundamentals. There will be problem solving by hand, and by that, for example, a hand style problem maybe would be a table lookup factor type question, or it could be an equation question, and I gave you those formulas, right, the full-fledged formulas, and I'll also provide that in the exam. I'll provide the table lookup factors you need, and I'll provide the equations, and so you don't need to prepare a formula sheet or a note sheet, nothing like that. For the computer-based question, the way that we're going to work it is that you're going to submit your file on iLearn. Which is the same way you submitted your first homework assignment. So I know that everybody already knows how to load a file onto iLearn because you've done it before. Our exam will be 50 minutes, and when I give you 50 minutes, my goal is to have it so that you can solve it in 30. So that people who need a little more time to think about it and maybe relax and eat some candy halfway through the exam, that was always my strategy, is I'd go into the test with a bag of candy, because I thought my brain needs sugar to keep active. So I'd always be feeding myself Skittles as I would take the exam. So if that's your strategy, I understand. Bring Skittles to the exam. Maybe it will help you out. Who knows? So my goal is to make it 30 minutes. Now, if you don't know the material that well, 50 minutes isn't going to feel like enough. So how much time you take on the exam sometimes depends on how well you know it, but since I naturally work kind of slowly, I don't try to make it so it's something I can solve in 50 minutes. I want it to be so that just the average student should be able to finish it in about 30. That's my goal. Any questions on exam 1? Yes? Definitions, I might, yeah. So a conceptual question for a short answer, I could ask you to define something. Yeah. Other question, yeah. Yes, it'll be during our normal class time. So it'll be exactly 1 week from today. Yes? It will be in room EB2 104. Other questions? All right. Well, if anything pops up, you can ask. We've still got plenty more lectures this week, or you could send me an email. So we're at the point where we're ready to start decision making. You've done present worth stuff before. This is called present worth analysis. And so what you're going to be doing is taking your ability to move money to the present and start comparing alternatives. Because that's the whole point of this course, is you're going to be in a position at some point when you're a practicing engineer to spend the company's money, or to spend the company's time, or even just use your own time. And you're going to be comparing options and trying to figure out which option is best. Should you do one thing or should you do another thing? Should you purchase the equipment from Mitsubishi, or should you purchase the equipment from Hyundai? So what this diagram is showing is that decision-making process starts out with brainstorming. That's what the cloud at the top is supposed to represent. is the idea generation process. And specifically, a mandate is, you can think of that word means like a command. The president of the company has a command that we're going to try and make a profit. You know, there's always sort of an implicit objective, and in a business it's usually to make money. And so the mandate is to do some project to generate revenue. And through the process of brainstorming ideas and gathering information based on your previous experience doing similar projects and looking through plans and estimating quantities, you come up with proposals, which is a specific focused idea of how you're going to take resources and turn that into additional money. So you have to spend money to make money, as they say. So you'll be taking your time, the equipment, and you'll be making that investment today to generate an income stream in the future. The proposals are evaluated, and the not viable proposals hopefully are set aside before they're implemented. But sometimes non-viable proposals sneak through. You know, we know of failed businesses all over the world. There are plenty of examples of proposals that weren't viable, but they were done anyway, either because there wasn't enough research, or people were making unrealistic expectations, or maybe the business environment changed. There's a lot of reasons on why things ultimately become non-viable. But let's say we, in the initial stage, identify 2 projects that we want to do, and what we have to do is, first of all, decide is what we're trying to accomplish mutually exclusive. And by mutually exclusive, that means sometimes you only need one solution. If your company is looking to buy an excavator, for example, then you choose between 2 providers, Mitsubishi, Hyundai, just as an illustration. If you buy Mitsubishi, that excludes also buying Hyundai, because you only need one piece of equipment. That's what we mean by mutually exclusive alternatives. Sometimes, independent projects, you can do as many of those as you've got the resources for. And so an illustration of independent projects is some companies have lots of different businesses. So if you take, for instance, Toyota. Just because Toyota makes the Prado doesn't mean they can't also develop the Corolla. Those are both vehicles that they can sell. They can have independent projects and do as many of them as they think there's a market for, and also as many of them as they have the resources for. So sometimes the project is mutually exclusive, and sometimes it's not exclusive. So what you're going to do in a mutually exclusive is you're supposed to choose between one of the options. And DN here stands for do nothing. And sometimes when you look at the solutions that are available to you, you decide to do nothing. And just as a very simple illustration of the do nothing approach, if you have 100 dirhams and you're investing it into a bank, and the banks are saying they'll give you -1% interest, -2% interest, then maybe it's better to not deposit the money anywhere. And that sounds like a silly example, but there actually are a few places in the world that have negative interest rates, where to store money with the central government, for example, I think it's in Japan where they have negative interest rate. And the reason why they're doing that is they're trying to encourage people to spend their money instead of saving it. They're trying to stimulate economic activity. And so if you were faced with the option of just keep your money under the mattress or put it in a bank and lose money, then you'd probably do nothing. You wouldn't choose any of the bank's proposals. And so if a project turns out to be not profitable, you do nothing. In the case of the independent projects, you'll first look at the do nothing approach, but then you'll consider all of the rest, and then you'll do all of them. You'll remember this figure, for example. I think we had the case of how much money you borrow and the borrowing interest rate goes up. Does everybody remember that curve? When then we also had these figures that were descending like that, something like this. And what we were saying in this diagram is you choose every project where your profit rate is higher than your borrowing rate. And so you wouldn't do a project when it costs more to borrow money than the rate of return on the project. And so that's the decision-making strategy that's used in independent projects. Now this next part, down here at the bottom, types of cash flow estimates. Sometimes a project has both revenue and costs. And so you make an investment and you get money in the future. That's usually private companies that have both revenues and costs. Sometimes governments and nonprofits only have costs and they don't have revenue. So take, for instance, a public park. Now, I know around here some public parks charge admission, but not all. There are some parks you can go to and you don't have to pay to get in. Well, the municipality has to pay for the grass, they pay for the laborers, the land, and so they have expenses, but there are no revenues there. Later in the semester, we're going to talk about how do you judge a project when it's not going to make a cash profit. You know, there are other ways, other things to value besides profits, and sometimes you just consider non-monetary benefits, like enjoyment and children playing on the playground. You know, there's other things in life besides money, and we'll get to those in the later half of the course. But for now, we're going to focus on revenue alternatives, which is the case of you're trying to have more revenue than costs. So here's some terminology that we've just been talking about. Mutually exclusive alternatives is when you're only picking one of the options. Independent projects are those where you're choosing as many as are profitable. The do-nothing approach is you just keep doing what you're doing now. And so do nothing literally, it doesn't mean that you just stop and stand in the corner. It means that you don't implement any of the new ideas that are being accepted. So maybe it means keep the old equipment. You know, if you already have an excavator that's, you know, it's working okay, but maybe it's not as big as you would like, or it's not as shiny as you would like, the do-nothing alternative means keep your existing option. And we've just talked about revenue-based projects and cost-based projects. So are there any questions so far about the concepts we've discussed on decision-making? All right, so we're going to be comparing alternatives. Now here's what we do. We're going to have different cash flow diagrams for our options. You know, option A, option B. So you take the cash flow to the present using the MAR, M-A-R-R, minimum acceptable rate of return. Now, if the projects are mutually exclusive, meaning you have to pick one, then how do you know which one to pick is the one that gives you the most money in the present? Because you'll be facing alternatives where maybe one of the alternatives generates a little bit of revenue for a long time with a certain cost. Maybe here is our option A, and then maybe our option B would look a little bit differently, where we have to spend, but then we get more revenue, but for a fewer number of years. So that old phrase, comparing apples to oranges, it means, what it really means is comparing things that aren't similar. Trying to compare dissimilar things. And so what's dissimilar about this is how long the project is generating revenue and how much. And so it's hard for us to compare it unless we take it all to the same time. And so we make these two things that are different, we make them the same by forcing all of the money to the present. And then once it's in the same time, we can compare the amounts, and whatever amount is highest is the alternative that we select. So that's why this method is called the present worth method, is our approach for comparing things that are different is by taking all of the money to the present. Yeah? Well, every company wants to maximize profits. And so I think what we could say is we could take both of these and we could do like a cash flow table, you know, where we have the unrecovered investment balance. And so the alternative that gives you the most money at the present is going to be the best whether you take it from the present to some other time. So we're doing today the present worth method, where we take everything to the present. There's another method that we're going to do on Thursday that's called the future worth method, where you take, instead of moving everything to year 0, you move everything to a different year, like maybe year 3. And if the present worth method tells you that option B is better, then the future worth method will always give you the same answer as well. So I think the case that you're bringing up, maybe you'll see how it works when we get to Thursday in the future worth method. But the nice thing I can tell you now is that you'll never get two different answers. If one of them is better according to present, it'll also be better according to the future worth method. All right, so here's the in-class exercise that I've given you for today. We're comparing equipment, Hyundai and Mitsubishi. We need to buy a new excavator, and each of these is going to last for 8 years, and so at least the time frames aren't different. But what we do have as a different is it looks like the Mitsubishi costs more than the Hyundai. So you have to pay $250,000 instead of $205,000. But then the benefit of that extra expense, you'll notice that the maintenance charges are lower. So every year you have to pay 22,000 dirhams to maintain the Hyundai, and you have to pay 20,000 dirhams to maintain the Mitsubishi. There's fuel costs for both, and it looks like another benefit of the Mitsubishi is that the fuel costs are lower, so somehow it must have a better fuel economy, and it's also generating a little bit more revenue each year, and the salvage value is higher. So the main thing we're trying to figure out is for all of those extra benefits, it looks like the Mitsubishi gives a lot of benefits, but are those benefits enough to justify the extra 45,000 dirhams that you have to spend in year 0? All right, so part 1 and part 2 are there on the page for you. I'll pause the recording so you can get started on that. I'll circulate around with the solution. All right, let's start by looking at the cash flow diagram. So we have to spend money at year 0 in order to buy ourselves revenue in the future. You make an investment now so that you can generate income. We've got the annual revenue, and I got a good question as I was circulating around. Somebody said, if both of these are excavators that are going to be doing the same job, why should you get more revenue from the Mitsubishi than you do from the Hyundai? Because you can see the Mitsubishi is giving you revenue of 95,000 and the Hyundai is giving you revenue of 89,000. And so a situation where that would be a case is if one of the equipment pieces is more efficient than the other, like if it can work more quickly. So it's an excavator, you can think maybe it has a larger scoop on the front so that it can move more soil out of the way, or maybe it can go from job to job more quickly. And so not all equipment will generate the same amount of revenue. So that was a good question. The fuel costs are different, making the Hyundai more expensive. It may have a different engine. So what you can see is that I have not yet combined the annual series together, although we could represent this as a single net cash flow diagram. Just as a starting point, I think it's best to illustrate the revenue and the cost separately so you can sort of visualize the pieces. When I do the calculations, of course, it's a lot simpler if we just find the difference between the income and the outflow, because to move all the pieces separately is going to take more steps. So just the typical thing is to combine for the calculations but leave it separate for the cash flow diagram. If you would like to do a cash flow diagram that only shows the difference, then be sure to label it net cash flow diagram and maybe underline net, because the grader or me, I'll be looking at the cash flow diagram and I'll be thinking, well, they forgot the fuel costs and the maintenance. But if I see you label it as net, then I'll reconsider and I'll say, oh no, they didn't forget. They just took the subtraction there. So I had the question also, what is salvage value? When equipment wears out and it's basically done, you can sell it for scrap. Or it has to go through a major overhaul before it's useful again. And so you can just think of it as a resale value at the end of its useful life. In the problem statement it says it will last for 8 years. And so that tells you when the salvage value is supposed to be applied, is at the end of the useful life. So any questions from the cash flow diagram part of it? Let's look at the calculations. All right. So you can see, just to make things easier on the calculations, I came up with a net annual. It would be the inflow minus the 2 outflows. So that was the 43,000. All right. So you find the net A, and the Mitsubishi, when you consider the initial investment, is worth $5,058. Okay, so it's important to be able to interpret what that means. You're not only making $5,058. You're making the MAR and that $5,058. So your overall profit is going to be higher than 10% because our minimum attractive rate of return is what we discounted at. Where does it say the MAR? It says it, on part 2, right. Use the present worth analysis to select the best alternative for I equals 10%. And so we're discounting all the money in the future to the present. So if that was your borrowing cost, if you were paying 10% to the bank to borrow the money, then after everyone got paid, after the workers got paid and you did your annual maintenance and fuel costs and everything, there would still be a leftover profit of $5,058. But in a lot of cases, the discount rate of 10% is different from the borrowing costs. So if you wanted to make 10% return, and this is greater than 0, then that tells you really you made more than 10% return. Okay, so the interpretation of this negative value for the Hyundai is that when you're discounting things at 10%, you're going to lose money. So if you were paying 10% to the bank to borrow the money, then you're not getting enough revenue to justify that original investment at year 0. So I'm going to put this onto Excel, and so we can play around with the I value and see at what point the Hyundai would become a good option, and see if that ever changes which one is better. I was glad, as I was walking around talking to people, someone said this would have been a lot easier on Excel. So that made me think you're already starting to see the beauty of Excel and how it can solve problems more easily than other methods. So let's do this as a cash flow table rather than a cash flow diagram. And we want to start with our interest rate, and it's 10%. And then here's year, amount. And we're going to set this up where we have both the Mitsubishi and Hyundai. Now these are going to be the actual amounts, and then this is going to be the PV of the amount. And we'll do that here. All right, so years 0 through 8. And then the net investment for the Mitsubishi is we have to pay $250,000. The Hyundai we have to pay $205,000. It's not as much fun to watch Excel as it is to do it, right? Are you jealous that I get to be the one playing with Excel right now? Yep. All right, so the Mitsubishi and Hyundai, we'll do the present values in just a moment. So the net benefit for the Mitsubishi was $43,000, and I'm going to drag that through all the way to the end, except for that then I need to change year 8 to also include the salvage of 55,000. So together it should be 98,000. All right, now the revenue for the Hyundai was 32,000. And we carry that through to the end, and then also add in the salvage value of 44. All right, so now we can use the PV function to find the present worth, our rate. I'm anchoring it by pressing F4. Here's our N. Why do I want to skip over the payment field? Because if I don't, it thinks that it should have that many and the payment is that amount. But really what we're doing is we're treating this 43,000 like it's a single amount, and we're moving it however many years back to the present. So we want to skip the payment field and use instead this as a future value. Let me change the formatting for that. So it makes sense that it should be the same because it's 0 years. It's not moving it any years. And I'll do that over. Oh, I didn't anchor the N. So watch this. Here, I'm going to anchor. I don't want to anchor both A and 4, because if I anchor A and 4, when I drag it down, it's always going to be looking at A4. But I can anchor just the column reference so that when I drag it sideways, it continues to look in the A column, but it won't always look at the number 4. So you know, here I was anchoring both the column and the row for the I, but here I'm going to anchor just the reference to, oh, that's the wrong one, just the reference to column A. And that way I can drag it sideways and it's still looking at column A for the year. So that's a little trick with anchoring. So now we can drag it all the way down, and our technique here is to find the total by summing up and that's what we get. Now, it's a little bit different from what you calculated. Why? How come when we did it on paper it was $5,058.20, and this is $5,059.73? Yeah? Yeah, this is doing it exactly. This is with no round-off error. And when we did it on the table, back to our solution, we were rounding off, for example, the P/A factor to 5.3349, and the P/F factor was only to 4 digits of precision. So we get unlimited precision when we use Excel. So this is exactly. All right. So one of the questions, the hypotheticals that I posed was, if we change the interest rate, is that going to make all of a sudden the Hyundai the better option? Like, is there ever going to be a case where a different interest rate would tell us choose Hyundai instead of Mitsubishi? No? All right, well, let's see. You're right, but let's just double check by taking maybe 1% instead of 10%. So still, Mitsubishi is better than Hyundai. You know, I'm going to do something called conditional formatting just to, let's see, where is conditional? There it is, conditional formatting. So highlight cells. Let's do that later. The difference between the two is maybe what we could say is how much better is Mitsu than Hyundai. So if that becomes negative, then that would tell us that the Hyundai is actually better than Mitsubishi. But at 1%, the Mitsubishi is still better than Hyundai. We were originally at 10%. Mitsubishi is better than Hyundai. What if we have 20%? Well, they're both looking pretty bad at 20% interest. If we have to borrow our money at 20% interest, then we should just walk away from this altogether, go out of business, because there's no way to make enough money. But if we know that we wanted to find out what is our rate of return, let's say we go with the Mitsubishi. We're going to buy the Mitsubishi. We want to find out what interest rate would give us this equals to 0, and that would tell us what is our actual rate of return. So at 10%, we're making more than 10% rate of return if we're doing the Mitsubishi, because we have 5,000 left over in addition to our 10% rate of return. So later on, after another way of comparing alternatives is to find out which alternative gives you the most rate of return. And so we could use the what-if analysis to say, what we want it to do is we want it to make this cell equal to 0 by changing the interest rate. And so it's going to go through and iterate, play around until it finds the interest rate 10.5%. And so the actual rate of return for the Mitsubishi is 10.5%. But we'll get into that a lot more in the future. Any questions on the Excel side of things that we did? All right, on the back side, it asked you to explain. Like, this is an illustration of a short answer that you could expect on the exam. It says, explain, how is it that the more expensive equipment is the best alternative? So, a lot of people don't understand the time value of money. So someone who's not acquainted with engineering economy may say, you're saying I should buy the Mitsubishi even though it's more expensive? Like, why should I spend more today if both of them do the same job? And so what are some of the things that you mentioned in your explanation on why Mitsubishi is better even though it's more expensive? Efficiency? More revenue? Less expenses. And so the argument that the way that you can help someone understand it is, yes, you're paying a little bit more now, but you're saving a lot in the future. But then what if they said, yeah, but future money is worth less than money now? What if they know a little bit about engineering economy and they came back with that? They say, I don't want to spend my precious present dollars because future money isn't worth as much. Yeah, so you said, well, I already thought of that. I took it from the future to the present, and I found out that even though it's true, present value isn't worth as much, future money isn't worth as much as present money. If you compare the savings, it's still worth the extra amount, even when you take it from the future to the present. So that was the whole point of the, yeah, so our original argument, our back and forth was, you said, you save money, that's why you spend more now. And then the other person says, but money in the future isn't worth as much. But when you moved the money from the future to the present, you were accounting for the time value of money. And so you were already factoring in that future dollars aren't worth as much as present dollars. And so you calculated that the extra amount you have to pay is worth the extra savings in the future. All right. So that's it for today. I don't remember if we're going to be, oh yeah, actually, no, yeah, we're here on Tuesday, but we'll be in the computer lab for Thursday and for the exam. So I'll see you here on Tuesday.